Okay. Alright folks, in today's lesson we're going to be learning how to predict the products of chemical reactions. This is kind of what we've been building towards all trimester, right? We've learned sort of about atoms, and then we really learned how they bond, and then earlier this unit we've been learning about chemical reactions and how to balance those reactions and identify what type of reaction we're looking at. And so now in today's lesson, what we're going to look at is starting with two compounds and then predicting how the atoms are going to rearrange to form the products. Okay, we are going to be using some polyatomic ions on this assignment. So here's your list of polyatomic ions. All right, so we've already filled these blanks in before, but I'm going to have you do it one more time just because it's going to be relevant for today. So in double placement reactions, the products and reactants are all ionic compounds, right? So magnesium nitrate and potassium iodide, those are both ionic compounds because they have one metal and one nonmetal. And the nonmetal from one reactant will replace the nonmetal from the other reactant. And so what I mean by that is the nitrate and the iodine are going to swap places. Now nitrate is a polyatomic ion, so all of that's going to stay together, the NO3, and move over to be paired with the potassium. And the iodine is going to move over to be paired with the magnesium, right? Because nitrate is NO3. Okay, so now magnesium is paired up with iodine and potassium is paired up with nitrate. Okay, now notice that I didn't move both nitrates over to the potassium, right? I'm just going to move one for now. And then my next step is going to be to balance each of these individual chemicals using charge. So each of these compounds gets balanced using charge. Okay, so first we'll do magnesium iodide. Magnesium, if you look on the periodic table, it's got 2 valence electrons. That means it's got a charge of +2. Iodine has 7 valence electrons. It means it has a charge of -1. So then if I were to balance this, I would need 2 iodine atoms to balance out that +2 charge. Okay, and so then with potassium nitrate, potassium has a +1 charge. That's because it has 1 valence electron. Nitrate, we'll look at our list, and you can see that nitrate, that's nitrite, nitrate has a -1 charge. So then +1 and -1 already balance out, so I won't need to add any more potassium or any more nitrate to balance this one. Okay, so now all I need to do is balance the reaction. So we balance the individual compounds using charge. We're going to balance the entire reaction using coefficients in front, right? And we need to balance the number of atoms. So I count 1 magnesium, I count 2 of those nitrates, 1 potassium, and 1 iodide. On the other side, I count 1 magnesium, 2 iodine, 1 potassium, and 1 nitrate. If you're confused at all about how I'm getting this count, you should talk to me. Okay, and so if we look, what's unbalanced here? Well, nitrate's unbalanced because we have 2 on the left side and 1 on the right side. Iodine's unbalanced because we have 1 iodine on the reactant side and 2 iodines on the product side. Okay, so let's start by balancing nitrate. So I'm going to put a 2 right here. That's going to double my amount of potassium and nitrate. Okay, so now we should see that potassium and iodide are off because we've got 2 of each on this side and only 1 of each on this side. So I'm going to double my potassium iodide, and that should balance everything out. Now we have 1 magnesium on each side and 2 of everything else. Okay, let's continue this process with a couple more examples. Oh, and then remember, you don't put anything in those blanks. So really, this is the way it would be written, is with nothing in front of MgNO32 or MgI2. Okay, so in our next reaction, we've got nickel phosphate reacting with aluminum fluoride. So again, our first step is to switch the nonmetals. So PO4, that's our first nonmetal, that's phosphate, is going to switch with fluorine. Right? Phosphate is PO4, so that's all going to stay together. Okay, so now nickel is paired with fluorine, and aluminum is paired with the phosphate. So we just switched the nonmetals. And look, I did not carry this 3 over with the fluorine. That's because we need to use charge to figure out how many fluorines we need. Okay, so let's balance these formulas using charge. I'm actually going to start with the second one because that one's going to be easier to balance. Aluminum has a +3 charge. That's because it has 3 valence electrons. It's going to lose those 3 valence electrons to gain a +3 charge. Phosphate, on the other hand, has a -3 charge, right? We can just see that from our chart. So -3, +3 plus -3 will balance out. Fluorine has a -1 charge. We can tell that from the periodic table. It's got 7 valence electrons, which means it's going to gain 1 electron to have a -1 charge. Nickel, remember that nickel is a transition element, so if we look at it on the periodic table, on the dynamic periodic table, it'll be one of those red ones. And those red ones, they can have multiple oxidation states, so we don't really know what the charge is. So what we're going to do is we're going to do a little bit of detective work, and we're going to go back and look at what it was paired with before and use that to determine the charge of nickels. Now remember that phosphate earlier, we found that it had a -3 charge, so that was still true in the beginning. So then what charge must nickel have had to pair with that -3 charge? Well, it had to have had a +3 charge. Because -3 plus +3 would balance out to equal 0. So since nickel had a +3 charge on the reactant side, it still will have a +3 charge on the product side. Elements can change their charge in a reaction. We call that a redox reaction. We're not going to be doing any redox reactions in this class. So for all of our reactions, each element is going to maintain its charge. So nickel was +3 in the beginning, so it's going to be +3 in the end. Okay. Last up, we need to balance the charge here because look, we've got +3 and -1. So how many fluorines are we going to need to balance the charge? Well, we're going to need 3 fluorines. That's what will balance the charge. Okay, and so then let's count the number of atoms, see if those balance out. On the left side, I count 1 nickel, 1 phosphate, 1 aluminum, and 3 fluorine. So 1, 1, 1, 3. On the right side, I count 1 nickel, 1 phosphate, 1 aluminum, and 3 fluorine. So hey, this one's already balanced out. We don't need to add any coefficients. So you can just leave all those blanks blank. Okay, so let's do one more example. This one we've got copper oxide reacting with sodium phosphate, sodium phosphide. Okay, so oxygen and phosphorus are going to trade places. So now copper is going to be paired with phosphorus and sodium is going to be paired with oxygen. Sodium has a +1 charge, that's because it has 1 valence electron. Oxygen has a -2 charge, that's because it has 6 valence electrons, so you look at the periodic table to get those two. Okay, this is unbalanced, we're going to need more sodium, so this is going to become Na2O. Okay, next let's do copper phosphate. Phosphorus has a -3 charge, that's because it has 5 valence electrons. Let's take a look at copper. We don't know what the charge of copper is, but we know that it was paired with oxygen, and oxygen has a -2 charge. So that means that copper must have had a +2 charge back when it was paired with oxygen at the beginning. So the formulas that I'm giving you at the beginning are already balanced, and so we can use them to determine the charge of these transition metals, and that will help us determine what charge they have on the reactant side. So this copper is also going to have a +2 charge because that copper had a +2 charge. Okay, so now we just need to figure out how many atoms of each we're going to need to balance it. Well, 3 coppers would have a +6 charge, 2 phosphates would have a -6 charge. So we're going to add a 3 next to the copper and a 2 next to the phosphide. Okay, now let's balance the number of atoms. So as I look at this one, I count 1 copper, 1 oxygen, 3 sodium, and 1 phosphorus. And then on this side, I count 3 copper, 2 phosphorus, 2 sodium, and 1 oxygen. Okay, let's balance this out. I'm going to start with coppers. I've got 1 on this side and 3 on this side, so I'm going to add a 3 here. That's going to make it so that I have 3 copper and 3 oxygen. Okay, next I'm going to do oxygen, because I've got 3 oxygen here, but only 1 on this side. So I'm going to balance that by putting a 3 here. That's going to change it so that I have 6 sodium, because 3 times 2 is 6, and 3 oxygen. Last up, we'll balance phosphorus and sodium, right? Because you can see we've got 6 and 2 here, but only 3 and 1 here. So if I double my Na3Ps, that will double my number of sodiums and phosphoruses. And now everything should be balanced. And then you can just leave this spot right here blank. Okay. There are 5 practice problems on the next page. Go ahead and give those a try. Let me know if you have any questions.